Hi, today's notes are on simplifying radicals and the Pythagorean theorem. Today is definitely a review day, so please make sure that you follow along, ask questions, try all of the problems, and make sure that you understand these two topics because moving forward, we're going to assume that these are pretty solid topics that you have covered and remember or can remember from geometry. So the first thing we want to review is simplifying radicals. So radicals are fully simplified when the number underneath the radical symbol, this, has no factors that are perfect squares. Perfect squares are numbers multiplied by themselves, like 5 times 5, or 3 times 3, 2 times 2, right? And the square roots of perfect squares are whole numbers, and written in front of the radical or outside, right? So if you have a perfect square like 100, then we don't even need the radical since there's nothing left inside. Now, the problem is when there's not a perfect square, right? Say like 48. Well, sorry about that. What we want to do and our goal is to make sure that the number underneath the radical has no factors that are perfect squares. So what do I mean? Like numbers that multiply to 48, if we take a look, you can do 2 times 24. I actually don't like to think of 2 because 2 is not helpful. It's not a perfect square. 4 is actually helpful. So 4 times 12 is 48, but 4 is still not the best number to think of. We want to take out the largest perfect square possible. So after 4 is 9, and after 9 is 16. 16 does go into 48, but 25 does not, right? So you see how like now we're getting to a number that's like way too big. 5 times 5 is 25, 6 times 6 is 36, and 7 times 7 is 49. So the biggest one we've got is 16 times 3. And so notice that my thought progression there was like, okay, I'll try 4s first. Then I can try 9, which is 3 times 3, 4 times 4, 5 times 5. Now, we know that the square root of 16 is 4. Please don't put that underneath the square root again, right? We've already taken the square root and used it to make the 16 smaller, but there is no square root of 3, so it's going to be 4 root 3. That's your final answer. I'll do a second example with you. Well, this one is 144. Some of you guys might know right away that the square root of 144 is 12, right? Because 144 is a perfect square. So since that's the case, your answer is just 12, and there's no radical needed because it's a perfect square. And I want you to recognize that. 73. I'm going to work my way up. Okay, so on a calculator, you could check 4s, you could check 9, 16, 25, 36, 49, and what you'll find is that there's actually no number that's a perfect square and multiplies to 73. So if that's the case, then 73, square root of 73, is already simplified, and that's all you've got. Now at this point, I do want you to go through and try these problems, 1 through 18. Tonight's homework is to finish this worksheet, so you might as well get started. Please don't just copy the answers here. They're at the bottom. My class is all about giving you the answers, but I really don't care about the answers. I care if you know how to do them. So I would suggest for the first few, please write out the perfect square that you've chosen with the factor that it multiplies to get to that number. Okay, so I want to see a little bit of work just for like the first few, and then you can start to do things in your head if you're able to. So 26, that's 2 times 13. That's my only option, so it's going to be square root 26. Okay, I'll do a few with you guys. 28, I can do 4s, 4 times 7. 16 won't work, so I think the best one I've got is 4 times 7. Right, that's 2 times 2. 3 times 3, 3 squared is not helpful, 4 squared is not helpful, 5 squared is not helpful. So this will be 2 root 7. Because if you break it up and think of square root of 4, that's just 2. Okay, I'll do another one just randomly. Let's do number 5 together. So number 5, 112, I'm pretty sure you could divide that by 4. But my question is, can I divide it by a number bigger than 4, or a perfect square bigger than 4? So what I would do is do 112 divided by 16. I skipped 9 because it's not divisible by 9, but you can check that. Oh, and look, 16 times 7 works. Now, what would happen if you chose 4? If you chose 4, you would have gotten 4 times 28, which is not simplified because this is not the biggest perfect square. So what that means is under 28, there's another 4 times 7, which is hiding, and that makes it more complicated because a lot of students will write 2 root 28 as their final answer, right? And that's not right because that's not done yet. So I want you to check all of the perfect squares. Just try to get bigger and bigger until you get just like a really small number here. Notice 7 can't get any smaller, right? So this is a good place to just stop. You could also check 36 if you wanted to. But you see how like that's a decimal, so it's too high, right? Okay, so hopefully that covers any questions you might have. The bigger the number, the more perfect squares you have to check. Remember, a perfect square is something multiplied by itself, or a number multiplied by itself. Okay? Let me know in class if you have any questions on that still. Let's move on to reviewing the Pythagorean theorem. So before we begin, please remember that the Pythagorean theorem only works for right triangles, and A and B have to be legs, the length of the leg, and C is the length of the hypotenuse. The hypotenuse, in case you forgot, is a side opposite the right angle. And since this only works on right triangles, there always has to be right angle, right? So then this is opposite the right angle. And so this longest side is the hypotenuse. If this is the case, if A and B are the legs and C is the hypotenuse, then A squared plus B squared equals C squared. Okay? Leg squared plus leg squared equals hypotenuse squared. It doesn't matter which leg you use. Hopefully you remember that from your geometry teacher, right? So it doesn't matter which leg you label as A or B. It just matters that the hypotenuse is by itself on the other side. Your numbers should also all be positive, A, B, and C, because we're talking about actual lengths and there are no negative lengths. So let's call it. We know this is C. And if we are finding the missing side, right, that means we can say this is x. So we'll do x squared plus 12 squared equals 13 squared, because C squared has to go by itself. So we have x squared plus 144 equals 169. Subtract 144 on both sides. I'll show all my work for you guys. Day 1. I think that's a 5, but let's check it just to be sure. It's 25. And then we're going to square root both sides. I like to write it underneath so I know that this step happened after, but it's not a big deal. And you get x equals. Normally in Algebra 2 we write plus or minus 5, but since we're talking about lengths, x can only be positive. Okay? We don't need to round. Let's read the directions. Sorry. Find the length of the third side of each right triangle. Write numbers as both exact values, which could be whole numbers or simplified radicals, and rounded if necessary. Nearest hundredth is 2 numbers after the decimal. Okay, I'm not going to give you this definition much longer. That I expect you guys to know. So if you take a look at example 5, there is no triangle, but we know the hypotenuse is this one. So this is my C. Okay? So I have x squared plus 1 squared equals to 2 root 11 squared. Now, I put parentheses around this to be very careful, because if I didn't put parentheses and I just did this, then this squared cancels out with this 11, square root 11, because it means there's 2 square root 11s. But if there's no parentheses, it does not mean that there are 2 2's here. This parentheses means that there's 2 2's and 2 square root 11s. So how does that work? Well, let's write this so that you guys can see it, okay? So I have 2, I have square root 11, and so this 2 gets distributed to both of them. Okay, so these two cancel out, and I have x squared plus 1 equals to 4 times, there's an invisible multiplication there, 4 times 11. So then I have x squared equals to 44, and I'm going to subtract 1 here, just for the heck of it, all together, okay? So I have x squared equals to 43, square root both sides. The squared and the square root cancels out, and 43 is a prime number, so you can leave it as square root 43. Okay. So please try the rest of these. I think I've shown you an example of just like whole numbers. I've shown you an example of like what it looks like when you have a radical or a simplified radical. And if you go in order, the problems should start off a little bit simpler. I did forget one thing here. I asked for exact value and a rounded value. So I need a second number here. That means I need to grab my calculator, square root 43, and I need 2 numbers at the decimal point, but that third number, 7, rounds us to 6.56. Okay? So once again, the next 5 problems are for you to finish. Answers are right here for you to check. If you think I've made a mistake, that's always a possibility. Don't erase your answer and copy mine. Please circle the problem that you think I've made a mistake on, and we can check it together in class. I count on you guys to check my work, just as you count on me to check your work. We can't all be perfect, and I will be making mistakes all the time, just like I expect you to make mistakes as well. I hope this was helpful, and you can come back and watch this anytime you want.